Hey everyone, welcome back. So in this presentation I'm going to be talking about how steel is classified, and we're going to be talking about how to identify different metals. So now when I say classification of steel, if we think back to previous lessons, we've talked about low carbon, medium carbon, and high carbon steel. We know that stainless steels are out there. Now, the reason that we have classification systems for steel is so that way we know exactly what type of metal we're working on. This is going to come into play depending on the job that we're doing. If we're working on bridges, if we're working on buildings, if we're working on something that's going to be part of a vehicle, if we're going to be working on something that's supposed to undergo a lot of stress being applied to it. So a lot of different things are going to factor in when you're choosing the type of steel to use for the project. And that's where these classification systems are going to help us pick the right type of metal for the job. So now if we think back to the video about metallurgy, let's recall that steel is an alloy of iron and carbon. So iron and carbon mix to create steel. And there are also additional alloying elements that are added to steel, whether it's on purpose to change some of the physical and mechanical properties, or if it's just residual as a part of the steel making process. And steel is something that we see or we use in our everyday life, whether or not we think about it. The cars that we drive are made out of steel. Some have aluminum, but for the most part, the frames are made out of steel. Some of the buildings that you might be working in have steel somewhere in the walls and the ceiling and the foundation. There's steel somewhere in there. Bridges, of course, have some steel, whether it's rebar that's reinforcing the bridge's foundation or the steel cables that are helping to stabilize the bridge over long distances. Of course, you'll see steel in your homes. Again, it could be part of the foundation, maybe it's part of the structure of the house, or just the appliances in your house. Washer, dryer, oven, sink, that sort of thing. Tools are made out of steel. Wrenches, sockets, screwdrivers, hammers, all those sorts of things. Our utensils, so knives, spoons, forks, all those different things can be made out of different types of steel. The point of this is just to say that steel is everywhere. And as long as we continue to make things out of steel, we have to make sure that we're choosing the right type of steel for the job. And again, this is where steel classifications come into play. And so if we backtrack a little bit, remember that steel is an alloy of iron and carbon. Now here's just a very short list of additional alloying elements that can be added to steel, and they're going to have an effect on steel by changing the physical and mechanical properties. So they're going to have an effect on things like right here, hardness. They're going to change the strength, the steel's ability to harden. They're going to affect the machinability, and of course some of them might have a cleaning effect. So here we have a more in-depth list. So we've got two little charts here, both of them with two columns. The column on the left is going to list the various alloying elements that could be added to steel, and then the columns on the right are going to show their effects on steel. So let's just take a couple of examples. The first one, let's take carbon. So as we start adding carbon to steel, it's going to start having an effect of the hardness. So it's going to increase hardness. It's going to have an effect on strength. Now, the effect it has on strength is going to be dependent on how much carbon. So if you add too much carbon, you're going to increase the strength, but you're going to increase hardness, but you're going to decrease strength. If you add just the right amount, you can get a good balance between the two. And then let's see, let's say we're adding some lead to the steel mixture. Lead is a very soft material. So by adding trace amounts of lead to steel, we're going to improve the machinability. So we're going to add a little bit of that softness to steel. So when we're going to mill our parts, or we're going to be drilling holes, it's going to be easier to work with a piece of steel. And let's take one more. Let's say copper. If we start adding copper in trace amounts, it's going to have an effect on steel by increasing its resistance to corrosion. So if the steel that you're working on is going to be exposed to chemicals, this is going to help that steel hold up to corrosion that would be caused by those chemicals. And so as we keep moving forward, there are different organizations that each have created their own system of classifying steel, or basically classifying metals. But for this presentation, we're going to be focusing on steel and only steel. So you can see here, here's a list of organizations that have each come up with their own system to classify metals. Now, instead of using all of them, depending on where you work, you might only use one or two. We're going to be talking about three. So the very first system of classification that we're going to be talking about is actually a joint effort between two of these organizations. The first one being the American Iron and Steel Institute, and the other organization being the Society of Automotive Engineers. So they came together to create one system of classification which is widely used today. And then the second system of classification we'll be talking about is created by the American Society for Testing and Materials. So let's keep moving forward. So the very first system of classification. This is a joint effort between the American Iron and Steel Institute and the Society of Automotive Engineers. Now the system that they've created that's used to classify steel uses a 4-digit system. So if we think back to the way that our welding electrodes are classified using letters and numbers, this follows kind of the same pattern, where depending on what the numbers are and where they're located in the classification, it's going to tell you a different piece of information about that steel. So here is the 4-digit format that this system follows. Now there are going to be some special occasions where you'll come across the 5-digit classification, but those are specialty steels, and we're not going to get into that a whole lot. We're just going to cover the basics. So let's stick to the 4-digit classification, okay? So the first two numbers are going to tell you the type of steel. Now, if we think back to types of steels that we've already mentioned, things like low carbon steel, medium carbon steel, high carbon steel, and even stainless steel, let's try to keep those separate. I know it could be a little confusing at first, but the first two numbers are going to tell you the type of steel. Now, this is based off of the alloying elements that are being added to the steel. So the alloying element that is being added to it the most, it has the highest percentage of all the other alloying elements. This is going to be the type of material, or rather the type of steel. The last two digits are going to tell us the carbon content. So this is where we retain those concepts of low carbon, medium carbon, and high carbon. These last two numbers are going to tell us the carbon content of the steel. I have a few examples for us. Let's take the first one, 1020 steel. The first two numbers, 10, are going to tell us that this is our basic carbon steel. And the last two numbers, 20 or 20, are going to tell us that there is 0.2% carbon within this piece of steel. So 1020 steel would be considered low carbon steel. Now let's take something like 1095 steel. Again, the 10 is going to tell us that it's carbon steel, and the 95 is going to tell us that there's 0.95% carbon within this piece of steel. This is going to be something that's considered high carbon steel. And so let's move on to the next one, 4130. So on the list of classifications, 41 tells that this is a chromium/molybdenum combination steel. So the two major alloying elements that are being added to this steel is chromium and molybdenum. Now the 30 tells us that there's 0.3% carbon. So this would be right along the edge of low carbon and medium carbon. And then we have 5130, which on the list of classifications, 51 would tell us that it's chromium steel. So the alloying element that's being added to the steel mixture the most out of all the other alloying elements is chromium. And then the 30 tells us that there's 0.3% carbon. So again, this one is on that fine line between low carbon and medium carbon. And then 6120 steel, the 61 would tell us that there's chromium and vanadium being added to the steel. And the 20 would tell us that there's 0.2% carbon. So this would be a low carbon steel, but it has chromium and vanadium being added. So here we have a more in-depth list of the various types of steels that are classified using this system. So for the most part, you can look all the way down and you'll see that most of them are 4-digit classifications. So the 10 series is carbon steel only. So there's not really any major alloying elements that need to be mentioned. Of course, there could be trace amounts, but not enough to really change the physical or mechanical properties of steel. And then we go to the 13 series. This is where we start seeing a higher presence of manganese. So out of all the other alloying elements, manganese has the highest presence. And then 23 and 25, we start seeing nickel being added to the mix. We start getting into our 30 series. We start seeing nickel and chromium. And then as we start getting into the 40 series, we'll see things like molybdenum, chromium and molybdenum, nickel, chromium, and molybdenum. So it goes on and on from here. So depending on what you're doing, how you're going to be preparing the material, what types of heat treats you might have to use, what welding processes, which welding electrodes, all these different factors are going to be based on what type of metal we're working with. Alright, so let's jump into the second system of classification. So remember, the organization that created this system was called the American Society for Testing and Materials. But now they've undergone a name change in the recent past, and they're now just called ASTM International. So the difference between this system and the other system before is where the first system that's comprised of 4 digits, that one focused on carbon content and the major alloying element. This classification system focuses on things like the chemical composition of steel. So again, a little bit of the alloying elements, but it also focuses on things like tensile strength. So every classification in this system is going to be based on both of those. It's going to include information on the chemical composition and the strength of that piece of steel. And it's going to be typically a letter followed by, 2, 3, maybe even 4 digits. So let's take a couple of examples here. Now, whereas the old system, the very first system that we talked about, where there's a precise list of steels, and there's a reason for that list because the first 2 numbers tell us the type of steel, and the last 2 numbers tell us the carbon content. This system is more or less arbitrary. So the letter and number basically are arbitrary. They don't really mean a whole lot. There's some meaning there, but their meaning is more or less, this is the classification we're giving to this steel, and you would take that letter and number and go to their code book and basically flip the pages until you come to that letter number designation. It's just a way of listing the metals, and then you would go to the code book to find out exactly all the details about this piece of steel. So the most common classification that's used from this system is A36. Now, if we were to go back to their code book and flip the pages until we would find A36, the code book would tell us that all these metals that fall under this category are standard for carbon structural steel. So basically carbon steel that are used for structural purposes. And it's going to give us an even more detailed list and explanation over the shapes of steel. So whether or not this steel comes in plate, if it comes in pipe, if it comes in round bar, if it comes in flat bar, if it comes in angle iron, things like that. And for each of those, it's going to tell you the minimum amount of tensile strength that that steel should have. And then it's also going to break down the chemical composition. The next three are just random three that I pulled out. So A48, if we were to flip the pages of the codebook until we get to A48, we would find all the information for gray iron castings. So basically cast iron and all the different ways that cast iron can be used, the tensile strength that is expected of that cast iron, and of course the chemical composition. And then A131, again flipping through the codebook until we get to that point on the list, it would tell us the specifications for structural steel for ships. So steels that are used in ship making. And then A368, if I were to flip all the way to that point in the codebook, it would tell us the specifications for stainless steel wire strands. So we're starting to look at cables, so stranded wire cables. So we'll start to look at the sizes of cable, how much tensile strength each strand should have versus the entire bundle of strands should have, what they're used for, things like that. And the classification system under ASTM is very, very lengthy. It doesn't just include steel. It also goes into stainless steels. It gets into aluminums. It gets into things like lead, manganese, copper. It even gets into things like ceramics. So their classification system is inclusive of basically every single material that can be used to build something, whereas the first system we discussed was for steel and steel only. Here are a couple of snippets right out of their code book. So I flipped all the way till I got to A36, and I've got them both highlighted because there are two charts here. One is going to tell us the chemical composition of the carbon steel for structural steel plates. So we can see all the different elements that are being added and in what amounts. And then the bottom chart is going to tell us the mechanical properties. So this is going to tell us stuff like the strength. So the tensile strength, yield strength, that sort of thing. So this is how the second system of classification lists their metals, or rather their materials. So just a quick recap before moving on. The 4-digit system that was made by AISI and SAE. The 4 digits focus on steel and steel only. The first 2 digits tell us the major alloying element to steel. And the last 2 digits tell us the carbon content. Now this system of classification is arbitrary. It basically tells us where in the codebook to look to find the information about this material. Now, there is a little bit of a system, at least with the letters. The letter A, all those classifications with the letter A would be for carbon steel. The letter B, if I recall correctly, is for non-ferrous metals. So things like stainless steels, aluminum, that sort of thing. And the letter C, I believe, is where we start getting into composites and ceramics. Don't remember the entire list, but if you're interested, you can always look up their website. Their codebook is available for view on the website, and you'll be able to see everything that they cover. It's really quite long, so I wouldn't recommend it now, but maybe in the future, if you're curious, you can give it a shot. Okay, so now that we know how steel is classified, what happens if the classification is nowhere to be found? What if we have an idea of what this steel is, but we need to know for sure? There are various different ways in which we can get a better idea of what type of steel we're working with. If possible, look for a packing slip. Look for any kind of paper label, or look to see if its classification code was printed or stamped on the metal. This is going to be a for sure indicator of what you're working with. If not, don't worry. There are other methods that we can use in order to identify the steel. We can use something called a grind spark test, where we take the metal and we take an angle grinder or a bench grinder and we grind the steel, or we grind the metal a little bit, and we look at the sparks. We look at the color, we look at how long they're shooting out, and that gives us a roundabout idea of what we're working on. Then there's the magnetic test, where we just take a magnet and we see if it sticks to the metal. And then there's also the scratch test. So this comes into play when you're taking something that is a known metal. So if you take regular carbon steel and you scratch another piece of metal with it, and you're really putting a scratch into it because it's a softer metal, then it's not going to be the exact same kind of steel that you use to scratch it. Now, if you can't scratch it at all, but then that piece of metal can scratch your steel, then, again, you can tell that that's not the same kind of metal that you're looking for. This is something that's harder, so it's probably something else. And so here I've got a couple of examples. So over here you can see a pile of magnets, and you can see some everyday steel items that are sticking to them. We have our shipping label, and then we've got someone who's just grinding steel. And so we can look at the color of the sparks, the shape of the sparks, so on and so forth. And so I've got some spark patterns here. So there's 8 different spark patterns, and they're all pretty much different, okay? You got some that are kind of dim. All right, we've got some that are really bright. We've got some that shoot really far out, and we've got some that don't really shoot far out at all. We've got some that are coming out as white. So all these different things are going to lead us to roundabout identity of the steel. And moving forward, these are all the types of metals that were trying to be identified in that first slide. So let's jump back real quick. So if you take a look, they each have a letter. So A, B, C, D, so on and so forth. And we jump to this list. This is the exact type of metal that we were seeing in the previous slide. So some other things that we're looking for in the sparks, we're looking for its profile, how it looks. Other than the color, we're looking for how the sparks behave. Are they just coming out as streams? Are they just shaped like little shafts? Are they coming out in shafts but then forking off at the tips? You know, are we seeing sprigs at the end of these sparks? Does it look like these sparks are coming out and looking like a bunch of dashes? You know, these things are going to all factor in when determining what type of metal we've got. And so here is another chart that can help with that. It's pretty in depth. So if you want to, you can go ahead and pause here, take a look at it, write down any sort of notes that you might need, and then we'll move on.
Okay, so here I've got various pieces of metal and I've also got a magnet. So this is going to be for the magnetic test. And to show you that this magnet works, I'm going to take this pipe. I'm going to take this pipe that I know is steel, and I'm going to take this magnet and I'm going to pick the pipe up. So this is just to show you that the magnet indeed works. So I'm going to use this magnet to test these different metals here, but it's important to note that a magnet is only going to be attracted to metals that contain iron. Iron is what gives steel its magnetic properties. It also gives stainless steel its magnetic properties, but it's also important to note that some stainless steels are not magnetic. I'm not going to go too far into it. We're just going to kind of focus on carbon steel for this demonstration. And then also, in addition to the magnetic test, another way to tell if a metal contains iron or not is whether or not it rusts. So if you leave metal outside and it's cold or it's rainy and you start to notice that it's starting to rust or what is technically called oxidizing, then you know that it contains some amount of iron. Still, it could be stainless steel, it could be mild steel. Not really sure. You know, we have to do further testing, but it's a way to narrow down exactly what you have. So let's go ahead and start with the first piece. So this piece is relatively shiny, it's very lightweight, and it creates sort of a dull sound when you tap it against something that is steel. Alright, so let's see if the magnet's going to be able to pick it up. So the magnet does not pick it up, so we can go ahead and rule it out as being carbon steel. And now it could be stainless steel, it could be something else. I know what it is, but I'm not going to give you the answer just yet. I'm going to wait until we go and test the other pieces of metal first. So now let's take the second piece. It's a little more mirror finished, sort of. It's shinier. It's a little heavier too. All right, so let's go ahead and test it with the magnet. So I'm feeling a little bit of a pull. It's not picking up the piece of metal, but I feel like there's some pull. I'm not sure if it's the steel tabletop underneath, so I'm going to go ahead and put it in my hand and then test it while I'm holding it. So there's a little bit of pull still, so there's probably a little bit of iron in this. But there's not enough there's not enough iron in this to make it carbon steel, so that rules out carbon steel and kind of gives us the thought that maybe this could be stainless steel. Now let's move on to the third piece. Now this third piece of metal is obviously smaller than the first two, and it's definitely lighter than the second plate, but for being this small size, it's about as heavy as the first plate. And let's go ahead and test that with a magnet. Okay, so it definitely picks it up, so we know that there is definitely iron in this. And so I feel confident at this point, you know, without a doubt, that this is definitely carbon steel. And let's go ahead and move on to this fourth piece of metal. And, you know, I see a little bit of rust on there, so that tells me that it probably has iron in it, or it was underneath something that was rusting and it sort of picked it up. But let's go ahead and take the magnet to it. So the magnet definitely latches on. It definitely wants to pick it up, but I think that this piece of metal is too heavy for the magnet to pick up. So I think it's just a weight thing here. So there's definitely iron in this. It's just too heavy for the magnet to pick up. It could be carbon steel, it could be something else. But because of the use that it's intended for and the texture of it, it could also, you know, tell you that this might be cast iron. And so we take this last piece of metal here. It's definitely a different color than the rest. I polished one part of it. That way you can see its true color. Looks like copper, could be copper. We don't quite know, but we're going to go ahead and test it anyways. And nothing whatsoever. So we can definitely rule that out as not being carbon steel. So, are you ready to hear the answers and find out what's what? This plate right here, this first one, this is aluminum. So the first clue in telling that this was non-steel and could be aluminum is, it's non-magnetic, and then also when you tap it with something that is steel, it has sort of a dull sound to it. And then also when you get more experience working with materials, you can just sort of look at it, see the scratches in it. You can look at the cuts on the edges, and you can kind of get more information like that to tell what type of metal it is. And you can also determine what type of metal you have by using what's called a scratch test. Aluminum is known to be very soft, so if you take a metal that you know 100% what it is and you try to scratch aluminum, if you scratch the surface of the material, it tells you that it's something softer than what you currently have, and so therefore you are not holding the same material in both hands. Now this one, the second plate, this is stainless steel. And so stainless steel is typically harder than regular carbon steel. So if I were to take this smaller piece of carbon steel and try to scratch the surface, you'll notice that I'm actually not able to scratch it at all. So, and just the opposite, if you were to take stainless steel and try to scratch steel, you would actually be able to put some marks on the surface of carbon steel. And the third sheet, we've kind of already established that it's carbon steel. And then the fourth piece of metal, the weight is actually cast iron. And the big giveaway here is not only that it's magnetic, but the texture of it. And I don't want to actually break this, but if I were to break this apart, you'd be able to look at the grain structure inside and see that it's very coarse. It's like open and coarse, and that's a key characteristic of cast iron. And this last piece of metal, this is actually copper. And you can see that it's two-tone. I took a wire wheel on a grinder just to polish this up, just to show you what it actually looks like. The more dull looking area is what copper looks like after it kind of starts to oxidize and pick up impurities. It also looks like it was kind of used to cool off welding parts. You can see some arcs on it. But yeah, this is copper.
So why does this all matter again? Well, depending on the metal that you have and depending on the job that you're supposed to do, it's going to require a lot of different things. It might require different ways to prepare the material. So different ways to bevel, different types of bevel, maybe different joints, different welding positions. It's also going to require a different welding process. Is this something that that can be accomplished using shielded metal arc welding? Or is it something that's going to require the use of gas tungsten arc welding? Is it going to require different welding electrodes or filler metal? Is it going to require a different type of shielding gas? And is it going to require some sort of special heat treatment, whether that's heating it up before you weld it, so preheat? And is it going to need any type of heating afterwards to stress relieve, keep it from becoming too brittle, things of that nature, so any kind of post-heat? These are all things that are come into play depending on the type of steel you have. So it's important to know how to identify the piece of steel that you're looking for, whether it's at the manufacturer's site and you're picking some up for your job, or if you already have metal at your job and you're just picking through, seeing what it is that you can use, or if you already have metal, making sure that it's the right metal. Maybe someone else picked it out and they didn't come in that day, so you're just kind of jumping on their job for them. So take your time with identifying metal. This is something that you shouldn't be cutting corners with. And of course, if you ever need help, ask somebody. It never hurts to ask someone rather than assuming and there being a problem later on down the road. I hope this information was helpful. If you have any questions, concerns, feel free to reach out. All right, I'll catch you in the next one.